Hello and welcome to C++ Weekly. I am your host, Jason Turner. In this episode, I'm going to cover a feature of C++ 23. I believe I've hinted at it before, but I did not really get the full implications of it until I saw a talk by my friend Andreas Fertig. Before we get going, I want to remind you that I'm doing a best practices workshop at ACCU Bristol on March 31st. This episode is sponsored by JetBrains, and I wanted to let you know that I do personally use CLion in my work. I find the refactoring tools to be particularly valuable. The safe delete feature has saved me a ton of time when I've been doing refactoring on large projects. I can get analysis of my compile time checks and see when something is wrong or fails to compile right here in my IDE. So be sure to check out the links in the video description for a discount code and more information about how you can check out CLion. C++ 23 gave us this feature. I can make a static call operator overload. I can also make a static index operator overload. So I might do something like this. And this allows me to just do that. I can just call an object of this type. That's kind of weird. Unfortunately, with C++ 23's rules that allow parenthesized initialization of a type, this is now thinking that I'm actually trying to construct an object of type callable instead of calling the call operator on the callable. That's unfortunate. So we have to come up with some way of actually calling this thing. I can do this, I guess, if I were so inclined. And then I have cannot initialize return object of type int with an L value of type int. Int. Well, we went down a weird rabbit hole. Let's go back here and try calling it with just an integer and see if it finds the right function. It doesn't. It's still trying to construct an object of this type. Oh goodness. Again, trying to call the constructor. And we find ourselves back here. There's probably some other way to do this, but we're allowed to invoke this call operator without actually needing an object of this type. What I had missed is that it's actually possible to use this static specifier on a lambda. On a captureless lambda, this makes a lot of sense. Like, a lot of sense, in fact. To the point where if this had been possible when lambdas were added in C++ 11, this would have actually been the default behavior for lambdas. Their call operators would have been static. So does this gain us anything realistically? And it potentially does. It gains us the fact that the compiler doesn't actually need an object of this type to call its call operator. So it doesn't need a pointer. It doesn't need to pass a pointer forward. And we're going to attempt to write some code that illustrates this, and we'll see if we can. This is an explicitly not defined function. Not defined, used in this translation unit, cannot be defined in any other translation unit because its type does not have linkage. So it knows that there can't possibly be a version of this coming up. This doesn't work. So there's no way for me to actually write this code. That's unfortunate. If I call this function like I am here with optimizations enabled, I'm going to expect this entire thing to be inlined anyhow. This code's going to go away, and we don't get to actually see that the compiler is saving a register here. Again, not helpful. Let's see if we can turn off optimizations and observe a difference in any way. This is the lambda function here. This is the useFunc, and we see that it is setting up EDI. That is the first integral parameter to that function, which is correct. That is the value 10. Let's remove static from here, and we can see that it now sets up the DI register to be a pointer to the value that was passed into the function, and the SI register is now the value 10. So with this debug build version, we can see that it is in fact actually saving a register. Well, that seems fairly insignificant, but I guess you could say, just trust me that in the context of a larger program, this actually has some real potential to let the compiler optimize more when it knows that it's calling a static function instead of needing that pointer to the object. So now it doesn't have to pass a pointer down to the function anymore. Yes, we can only observe this in the use func code at this moment, because the compiler just simply has too much visibility into what we're trying to do here. Hopefully this made some sense and it made you think, should static be the default for when I am creating a captureless Lambda? And the answer would be maybe. Something for you to consider and think about. You're definitely conveying more information about the nature of your Lambda here to the reader of your code and to the compiler. I don't know. Leave your comments below, let me know what you think, and thank you for watching this episode of C++ Weekly.